Hi YouTubers, welcome to the third installment of this series of videos that's going to show you how to build a chess engine from scratch in the Java programming language. In the last two episodes we focused mainly on the tile class. In this episode I'm going to flesh out pieces of the piece class, and that's going to let us create different pieces in our game, so like a knight or a bishop or a queen, a rook, a king. And so in this video we're going to be covering the abstract common class called piece that all different pieces are going to inherit from. Before I do that, there's a couple of things I wanted to say about where we left off in the last video. One is that I forgot to actually make the subclass constructors private. So I've done that here in this video. You can see occupied tile, that constructor is now private, and the empty tiles constructor is private as well. In the last video I did make the tile classes constructor private, and I wrongly stated that we had two classes, tile and piece, but we actually have tile, piece, empty tile, and occupied tile. Those are the four classes we have. But we have two class files. One of our class files, if you'll remember tile, contains declared inside of it two of its subclasses. So if there's anything else that I want to nitpick on, let me restate that. There's one more thing I want to nitpick on. One is that this call right here to immutable map copy of, some of you might notice that you can also, if you didn't want to import Guava, you could have also used the JDK's built-in collections.unmodifiable map and pass that the empty tile map and simply said return, here on this line, return collections.unmodifiable map. I prefer using Guava because it has a lot of sort of handy libraries that make programming easier and also less error prone. So I chose that. I chose to import that library and use their version of the immutable map, which has some benefits over collections.unmodifiable map that I won't cover here, but I'll leave up to you. If you want, you can use collections.unmodifiable map, or you can use Guava's immutable map.copy of, which will effectively allow you to have an unmodifiable map. And so if anybody comes along after this method is invoked here in this map declaration and tries to add more entries or clear it or mutate that container, they will get a runtime exception. So in my version I'm going to go ahead and delete that line and keep the version that I had. And if there's any other thing that I wanted to do here, it would be to rename this variable to empty tiles cache, just because I think that is a little bit more descriptive. And on my keyboard for my bindings I had to type in shift function F6 to achieve that rename. And if you're not familiar with your bindings and you're okay with clicking, you can also right click here and refactor rename to achieve the same effect of renaming that variable. And it's a really convenient function of the IDE because it'll rename that variable everywhere. You won't need to sort of go in and do it manually. Okay, so having said that, let's go in and start fleshing out our piece class. So here I'm going to start by saying that every piece has a piece position, that is to say a tile coordinate that it is occupied on. So let's go ahead and declare a protected final int piece position member field, and also the piece will either be white or black, so it's going to have an alliance. So I'm going to create a new protected final alliance piece alliance. And obviously we don't know yet what piece alliance is. We haven't declared that yet, but we will. And there's different ways you could do this. You could declare this as a class on its own, I'm going to declare this as an enum, and I'll assume you know what an enum is. If you don't, you can look it up. But it's kind of like a class. Okay. Here, let's go ahead and say that piece, final piece type, final piece position, and final, that's not right, final int piece position, sorry about that, and final alliance piece alliance. Let's pass those two things in and say this dot piece position is equal to piece position. Piece alliance is equal to piece alliance, and this dot piece position is equal to piece position. Sorry about that. And so now the only error that we're getting is that IntelliJ is telling us it knows nothing about this alliance thing. So why don't we go ahead and introduce that? And what I'm going to tell you now is that the alliance is going to be useful for not just pieces, but also players. So I'm not going to declare that in the pieces package. I'm going to come out here and I'm going to declare a new Java class, and I'm going to call it alliance. And it's not a class, it's an enum, and we'll see why that's useful in a minute. So now I've got this alliance enum, and I'm going to come back to my piece, and we should be able to now, import that. Great. Now we have the beginnings of a piece class. Again, it takes a position and an alliance, and our constructor will establish those member fields. And at this point, the most important method for us to look at on the piece class is a method that's going to be responsible for calculating the legal moves of a piece. Okay? So let's go ahead and say we have public abstract list of moves, calculate legal moves. And to do that, we're going to need a board. Final board. Now, a lot going on here, right? So first, what I said was that we need to calculate the legal moves for a piece, okay? That is going to return a collection of moves, okay? Now, there's a lot of things we could do here. We could return a set because the moves are not really ordered, so technically it's a set. Or we could say, we could leave it to be unspecified and return a collection. For the sake of simplicity in this exercise, I'm just going to return a list of legal moves, okay? And we haven't really defined what a move or a board is yet, so why don't we go ahead and do that. And so let's declare a move within the board class for now. So let's go ahead and declare a new class called move within board and import that. And import that. So now we know what a list is and what a move is. Let's make piece abstract. And a board, obviously, is going to be in the board package, new class board. And we have not defined yet anything about a board, but we will in subsequent videos. Okay. So, So this is probably the most important thing about a move that we've defined. So we've defined a move we've defined the piece class with one abstract method called calculate legal moves, and all of our pieces, all of the pieces that we're going to create are going to override this and have their own behavior defined for how it is. For example, how it is that a knight calculates its legal moves is very different from how a bishop calculates its legal moves, or a rook or a queen, etc. So each of what we're going to see in subsequent videos, when we go through each piece, is they're going to extend. A knight is going to be an extension of a piece, and it's going to override this method. And we're going to add other methods to this class as well, but at this point, really what I wanted to do was just sort of introduce the piece and the most important aspect of it, which is the calculate legal moves. In subsequent videos, we will look more closely at what it's going to take in order to calculate each piece's legal moves.